Hello everyone, I'm Sawaizam Anzu from Department of Physics, Manipur University. Today I'll be presenting on the topic visible light-driven photocatalytic activities of metal sulfides synthesized by simple co-precipitation method. As we all know, water pollution is one of the major threats that humankind is facing presently, and researchers and scientists among the world have been developing several processes and techniques for the treatment of the polluted water. And among the techniques, photocatalysis is one of the most efficient wastewater treatment because of its simplicity, low cost, and high efficiency. And moreover, it completely degrades the complex organic pollutants to harmless products such as water and carbon dioxide. It involves the light source and a catalyst material, which are mainly semiconductor material, and catalysts which are active in the visible region are gaining the interest of researchers because of its ability of maximum utilization of solar energy, which is the most abundant natural source of energy. In this present work, the photocatalytic efficiency of cadmium sulfide and zinc sulfide were studied and compared towards the degradation of melaside green dye under visible light irradiation. First, the metal sulfides were synthesized using co-precipitation method. First, aqueous solution of the precursor material was taken, and for cadmium sulfide, cadmium chloride was taken as the precursor material, and for zinc sulfide, zinc nitrate hexahydrate was taken to be the precursor material. It was stirred for 30 minutes, and after stirring to that solution, aqueous solution of sodium sulfide was added dropwise, and it was kept under constant stirring at 600 rpm for 2 hours. The precipitate obtained was collected and dried in a hot air oven at 60 degrees Celsius for 24 hours, and the dried precipitate was then ground to obtain the metal sulfide nanoparticles. The obtained metal sulfide nanoparticles were further used for the photocatalytic process. The photocatalytic experiment was done in a custom-made reactor, which involves a magnetic stirrer and a light source. The aqueous solution of the melaside green dye containing the catalyst was irradiated with the help of an LED bulb. After equal intervals of time, some portion from the dye irradiated solution was taken and its absorbance were measured using spectra shoot a UV visible photometer. And for calculating the degradation activity of the sample were calculated. The structural property of the samples were investigated using XRD. From the XRD spectrum, both the sample were observed to be cubic crystal, and their crystallite size were calculated using Device-Error formula, and their crystallite size were obtained to be 3.2 and 3.3 nanometer respectively. The optical property of the sample were investigated using UV visible absorption. From the absorbance spectra, the energy band gap of the samples were calculated, and it was found that zinc sulfide has an energy band gap of 3.9 electron volt, and cadmium sulfide has an energy band gap of 2.5 electron volt. The photocatalytic activity of the sample were studied, and cadmium sulfide was observed to be the more efficient photocatalyst, which degrades 95% of the dye under 2 hours of visible light irradiation. This may be because of the low band gap that cadmium sulfide has. Since it has low band gap energy, visible light is able to excite the electrons from the valence band to the conduction band, which create electron-hole pairs. And these electron-hole pair are necessary for the photocatalytic degradation of the organic melaside green dye. In this work, metal sulfides that that is cadmium sulfide and zinc sulfide were successfully synthesized using simple co-precipitation method, and their structural and optical properties were also investigated using XRD and UV. The crystallite size of the samples were observed to have 3 nanometer, and their energy band gap were calculated to be 2.5 and 3.9 electron volt, and the metal sulfide, that is cadmium sulfide, having the low band gap energy, was observed to be the more efficient photocatalyst, which degrades the organic malachite green dye up to 95% under 2 hours of visible light irradiation. These are some of the works that have been referred while doing this present work. Thank you all.